So to work out the average value, I need to work out the integral. How do I work out the integral? I start by graphing the function. Clear that. I want to graph the function 164,000 times e to the negative 0.06 t, which is x here. I hit graph. I don't see the function at all because it's all really big. That's okay, I don't really need to see it for the thing to work. The thing I do need to do, I'm about to get an error, because when I tell it to integrate from 25 to 30, it's going to say I can't do that because I didn't graph the function out to 25 and 30. The function being above the box doesn't matter, but I do need to, my left-right window does matter. I only graphed it from negative 10 to 10, that doesn't include 25 to 30. I go to window to change that. I'll go from 20 to 35, I guess. Just because it makes the picture prettier. Let's get a y value where we can see something. This function started at 160,000. If I go up to 300,000, I should see some function. Hey, there's some function. Uh-oh, the value of my house is going down over time. Let's calculate the integral from 25 to 30. It's got 158,072. With that 1/5 out front. I need to take that number and divide it by 5. I get 316.14. $316.14. That something feels off here. What is off here? Did I graph the function right? 164,000. Oh, okay, I guess this is right. My house is down to 30 grand. That's not great. Estimate the average value of this function over the interval from 1 to 4. Hey, I'm doing an even because it was easier to copy the number. Oh no, my graph didn't show... I didn't get the part of the graph that shows the values. That's 2, that's 4. Okay. Not you. So this is 2, and this is 4, and we want to know what's happening from 1 to 4, so that's from here to here. This is the part of the graph I'm looking at. To estimate the average value, I'm looking for where do I put the y value so that the stuff above the line is the same as the stuff below the line. Well, this is way bigger than this, so that line is too high. Let's scooch it down a little. If I try putting it here, how does that look? So now I've got this area is supposed to match this area. Oh, but there's also this tiny little fraction here that gets lumped in with the other above stuff. I think this part is still too fat. Like the bottom, this looks bigger than that, right? I don't have to count boxes to see that. If I go down to here, what do I get? Okay, this hump is a lot smaller now. This line is a lot bigger. Yeah, this looks about right. Something like this. Looks like the average value is about 5. So, I use that to estimate the integral. That's because the average value is 1 over the length of the interval times the integral. So to get the thing, I need to multiply both sides by 3. 15 is about the integral. Cool. Find the area bounded by these curves. I want to graph them. If I graph them at standard zoom, I see this, the cosine functions being all wavy. The line x over 5 looks like it's crossing it a few times. I think I need to zoom in to see where exactly. What can I see here? Function, cosine part, x part. Okay, I need a window to go a little further out. Let's go -5 to 5. Let's make the y values like -1.5 to 1.5. Sine and cosine stay between -1 and 1, so I don't need to go anything out there to see what's going on. Okay, that looks a lot better. Doop, doop, doop. Okay, the line is going up too high here, down too low here, so we have everything we care about. I'm looking for the total area bounded by these curves. So that's going to be 2 chunks. Down here, guy. These curves cut the world into, what, 1, 2, 3, 4 parts. We only care, oh, I guess there's this part too. We only care about the bounded ones. The parts that are bounded are this part and this part. We're going to have to do those as separate integrals because which function is on top changes from chunk to chunk. To work this out, I need, what are these 3 points? Those points would come from solving cosine x equals x over 5. Don't try to solve that. That's not the type of equation we are good at solving. So I'm just going to get my calculator to give me some digits on where are these points. I say, where'd my calculator go? No, where'd my cursor go? Please calculate the intersection between the first curve and the second curve. I only have 2 curves, so it's going to give me the right thing. My first guess is it looks like there's one over here. That's x equals 1.306. What else do I got? I want to calculate another intersect. First curve, second curve. My guess is I want the one that's over here. This one is at x equals -1.977. And then I want calculate the intersect between the first curve and the second curve over here. That first curve, second curve, I'm picking which 2 functions. I've only graphed 2 functions, so I can just mash enter through that part. This one's at x equals -3.837. So what we want is the integral from -3.837 to -1.977 of the top function, x over 5, minus the bottom function, cosine x. That'll be this area. Plus, we want this area. That'll be the integral from -1.977 to 1.306 of the top function minus the bottom function. Well, if I put them in the opposite order, if I just do x over 5 minus cosine x again, that'll give me the right answer, but negative, I will fix that with a negative sign out front. If I do it this way, I only have to graph the one thing. Let's graph that one thing. My one thing is x over 5 minus cosine x. Let's hit graph. There's the one little hump, there's the second hump. This thing equals 0 where they crossed each other, so there's here and here. I want to calculate the integral from -3.837 to -1.977. That'll be, this area is 0.4779. And then when I tell it to calculate the other integral, this will come out negative, but I'll fix that myself. The integral from -1.977 to 1.306 is this area. is a negative number, negative 2.104. So this area is